Hey, hey, hey. Okay, so now you sort of know about piecewise functions, so you might be saying, well, why are we learning those? It's because of our next topic. Are you looking at the wall at the list of skills? Because I think this is the next one. Absolute value functions, okay? So, can you guys just pause this video in a second here? I just want to know, I'm going to give you the algebraic form. You give me the graph form for f of x equals the absolute value of x plus 4, okay? So look at that thing, and then pause video and see if you can graph it, and I will wait right here. Go ahead. Okay, hopefully you made a table, and if you made a table, you probably realized something interesting happens when x is negative 4. When x is negative 4. So, bam, bam, and then right at negative 4. 1, 2, 3, 4. Okay. If you have the right answer, it should be going like this. Something here. Wait, I actually have to hold the paper in front of me like that, and then it should bounce off the x-axis like the x-axis is a mirror, and bam, like that. And this is at 1, 2, 3, 4. So so that was the graph form. Now you may have done enough piecewise functions to realize, wow, that looks a lot like what could be a piecewise function, right? Doesn't it look like before negative 4, we have one rule in operation that's given us this downward slanting line, and then after negative 4, we have another rule that's in operation that's giving us this upward slanting line? That is exactly the case. We have a piecewise function here, and I think we can probably even reason out what the two functions are. I'll tell you what, let me give you a shot at that so you don't just hear me droning on about what all the right answers are. Can you pause the video now and see if you can't write this function in piecewise notation, okay? You probably already know there's going to be a top and a bottom here, and then I need the x values that the rules are good for, okay? So pause video, see if you can get it. Okay. So here's what I have. My wrist is actually hurting because I'm holding it at such a weird angle. Um, so here's what I actually get when I do this. This line here is actually pretty easy for me because it's when x is greater than negative 4, right? That's the x values it's good for. Well, just think about it. Do you agree with this statement? When x is greater than negative 4, what's in the bars? Is it positive or negative? Isn't it positive? So if you put in like negative 3.5 or 0 or 1,000,007, isn't this going to be a positive number? So what do the bars do if the number inside is positive? Nothing, right? If what's in the bars is positive, the bars do nothing. So in other words, it's just x plus 4, right? So watch. This function just boils down to x plus 4. And where is that good for? It's when what's in the bars is, I shouldn't say positive, or 0 too. So I'm going to write it in sort of a weird way, but hold on, I'll clean it up later. This is what we have as long as what's in the bars there, oh, jeepers creepers, I can't erase, is greater than or equal to 0, okay? Yes, I threw 0 in there also, but I think that's probably okay, because check it out. If you put negative 4 in here and you get 0, that is my function value right there, right? So I'm not doing incorrect math there. Okay, are you okay with that so far? Okay, now look at this line here. Can you tell, I don't know if you can, its slope is negative 1. And if you were to carry down its line, like if I were doing this on graph paper, do you know what its y-intercept would be? Can you tell? It would be negative 4. In other words, this line here, if you just think about mx plus b, slope is negative 1. So we have negative x. Okay, you probably can't read that. negative x minus 4. That's what that rule is. Negative x minus 4. I'm hesitating because everything that I'm writing right now is backwards, like it's in a mirror. Okay, so that's a minus sign there. So we have negative x minus 4 here, and that's only for the values of x that are less than negative 4. So that's when x, when what's in the bars is negative, right? Darn, I kind of went into my graph area there. Let me just draw some. Okay, so that is the rule that you should have had, almost. It could use a little bit of cleanup here. The reason is that usually people just have, when they're putting down the x values that the function is, for which rule you look at, top or bottom, usually it's just x is greater than or less than something. X is greater than or less than something. So do you mind if I just subtract 4 from both sides and subtract 4 from both sides down here? That's legal to do, right? Like if x plus 4, if you got a something which is less than another thing, if you take away 4 from both of those things, the relationship still holds, right? That this guy would be less than this guy. Yes? So let me just rewrite this in final form. F of x equals negative x minus 4. And if I take away 4 from both of those, I'll have x less than negative 4, right? And then x plus 4 when x is greater than or equal to negative 4. There. I think that's right. Okay, so I'm not quite done talking about the top line here. I kind of want to make a statement that's parallel to something else that I did. Do you remember when I said, hey, if what's in the bars is positive, what did the bars do? Nothing, right? They do nothing. So that's why if this is positive in here, I can just drop the absolute value bars and that's exactly what I did, right? Down here, and then I cleaned it up down here. So that if what's in the bars is positive, just pretend it's x plus 4, easy peasy. Now think about this. If what's in the bars is negative, what do the bars do? They make it positive, right? So that won't be as good a way to think of it as this. If what's in the bars is negative, yes, you can think of it as that the bars make them positive. Couldn't you also think of it this way? That they slap on a negative to that negative value? Which is going to sound silly to you, but just here, look at, I mean, like if you have negative 2, okay, is that a negative number? Of course, right? Yeah. What happens when you put a negative on it? Then what number do you have? Don't you have positive 2? So one way to think of this, these bars, is this. If what's in the bars is positive, they do nothing. If what's in the bars is negative, they negativize that negative. And that makes it positive, right? So if what's in the bars is negative, just like we have negative 2 here, what do the bars do? They negativize that negative, which guarantees a positive number, right? The nice thing about that is it makes it easy for us to think about what this function must be here when what's in the bars is negative. So can you tell that if you negativize x plus 4, you end up with this, negative x minus a 4? That's all I did. For the bottom row, it's easy. If what's in the bars is positive, I just have without whatever it is without the bars. And then if what's in the bars is negative, what rule do you end up with? Just slap a negative on that thing in the bars, and you're good. Negative x minus 4. And then that's only good for when what's in the bars is negative. So that's how you turn absolute value like this into a piecewise function like this. Or as I should say, the final version, like this. That is handy. The window just blanked out on me again. That is handy to be able to do because these can be tricky looking at them like this. Like here, let's do another example. Why don't let's just see the difference between this thing right here and then something that looks very similar to it, okay? Why don't you guys try to graph. Can you hear the fan going in this? It's not even that hot out, and my laptop fan is running. Why don't you try to graph that guy right here, and then see if you can put it in piecewise function. Piecewise notation using those two kind of reasoning things that I say, where I say, okay, if what's in the bars is positive, what do the bars do? And if what's in the bars is negative, what do the bars do? So pause the video, graph this, and put it in piecewise notation. Okay, hold on just a second.